Learn about the AWS SageMaker, how it is working in the industry perspective. And this is the actually I went to the AWS SageMaker. In that here we can create in the studios also we can use it, and also notebooks are also there. Actually, I have created the notebook. So the main purpose of this particular project is in order to train the model and training, testing and deploying the model in the AWS SageMaker. For that, I have used ml.m5.xlarge. Xlarge is nothing but it's a CPU. M5 is nothing but ml.m5 is nothing but it's a one type of server we can say. So in this particular server, this is the CPU. So in that, I am going to open the Jupyter notebook here. I have created already. So I want to explain it once again. This is the notebook. Will take some time. Here whatever the model and also all the files related to it, XGBoost model, and all these files are there because I have done all. I have deployed already the model. So here it is the code. So you can see it here. I have whatever the dependencies that are required in order to deploy the model. So in order to train the model and deploy the model. So here all these things are there. And then the another thing is here US East 1. So this AWS SageMaker or AWS services they are providing means, for example, data centers will be there for AWS services. So in that US East 1 is a one type of in this particular location one data center is there. From that data center I am going to get the access to the AWS services. And Boto 3 is a library. From that library only, so whatever the, for example, in order to connect to the AWS services, means whatever the AWS services are there, in order to connect to the AWS services by using this Python code, for that Boto 3 is useful because we should have to connect to the AWS services. So by using Python code like that. And here get execution role means IAM role. IAM role is one type of set of permissions will be there because AWS SageMaker should have to connect to S3 bucket, and also another thing is EC2. It should have to connect to other AWS services. For that, so set of permissions are required. So that's it. Here bucket, so S3 bucket we can say S3 bucket. In that bucket only I have stored the means we can store anything such as a trained model, trained data set, trained model like that. So this is the S3 bucket name we can say. In that bucket we are going to store the total data, whatever data we want it here. Here what is going to happen? Here authentication it is going to happen. So whether it is a S3 bucket, so what is the bucket region? So like that, this is the thing what is going to happen. And also from the scikit-learn contains internally some data sets will be there. So internal data sets will be there. So here, so from that I am going to fetch California housing data set. So here means whenever this particular function is called, whenever this particular object is called, so then automatically it will call to the dataset loader, and in the dataset loader it will fetch whatever the California dataset is there. It will fetch that particular data. So and we are going to split that particular data into train dataset and test dataset here. And after the train dataset, it is converted to the data frame firstly. Whatever the train dataset is there, it is in the form of array format. So array format it is there, but we are going to convert to the data frame. So it's a tabular format. And in the train dataset, in the by train dataset, so we are going to put target value. That's a target value. Target feature is a will be there in the by train dataset. Means that dependent variable will be there now. So target value that is stored. So here also the same thing is going on here. And after that, what was happened? Whatever the data, train data set and test data set, x train, y train, x test, y test, whatever the data we are going to get. that will be stored in the S3 bucket. So I'm going to put the bucket name here. So that's a bucket name. So bucket name I have given as California 112, I think so. That's a bucket name. So that based on that. And after that, these are the dependencies what we are going to take it. And in that model function is there, so it is this particular function is useful for whatever the pre-trained model is there, so that is stored in the directory. Whatever the pre-trained model that is stored in the directory, that will be loaded here by using this particular function. And here parse arguments are there, means whatever the trained data set, test data set in the S3 bucket, and also pre-trained model where it was stored. So all these stored values means it will read all the stored values, means for example where the model was stored in the S3 bucket, and also where the trained data set and test data sets are stored in the S3 buckets, at which particular path those are stored. So all these things it will read, and these things, whatever the information it has gathered, it will be useful in the further, it will be useful in further tasks here. And after that we are going to do the yes. And after that what is going to happen, we are going to load the data. So train data set or test data set, for example if it is present, if the particular path, train path or test path is there, if it is started, the path is started with S3 means, then it is stored in the S3 bucket, we can say. It will be stored in the S3 bucket, we can say. And we can, whatever the data in the S3 bucket, we are going to retrieve that particular data. So that's it, we are going to load that particular data, we can say. So if the particular path of train path or whatever the train data set path or test data set path is not starting with this particular S3 means, then it is stored in the local area only. That particular data set, train data set or test data set will be considered as it is stored in the local path. So in the local area, we can say, not in the S3 bucket. So then in that case we should have to do like that, we should have to fetch data by using this pd.readcsv. So like that. So this is the hyperparameter tuning. For that, a number of estimators, how many number of decision trees we are going to take, maximum depth of tree, minimum sample split, all these are the hyperparameters, we can say. We have used it for that. Estimators, how many number of estimators we can use, maximum depth of tree should not be very much higher than overfitting takes place. Sample split, in order to split that node, how many number of samples are required, all these things are there here. And after that we are going to train the model. So we are going to take the hyperparameter tuning loop here, so for the random forest. And after that what is going to happen, it is going to calculate the metrics here, whatever the metrics are there, root mean squared error and also mean absolute error. So these are the loss functions are calculated here. So it should have to calculate the mean absolute error and root mean square error. The average should be considered. So here combined scores will be considered here. So why these are considered, whichever model, because in hyperparameter tuning, whichever model is having very much lesser, means third lesser, means the top three, means whatever the mean squared error and mean absolute error, if you are going to take the average of it, we are going to get the total value, average value of it. In that value, what we are going to do, take, so whichever model is having very much lesser means value, that particular model we are going to take. But it is, if the mean squared error and mean absolute error average value is very much lesser means, then it is a totally highly accurate model. So it is highly overfitted model, we can say. So that's why we don't want like that. So that's why we are going to take